In this lesson, we'll be talking about tangents, and this will be tangents to the circle. So, in one of the lessons, we have introduced tangents, and we have defined a tangent as a line that touches a circle at one point. You can see that if we've got tangent AB, it cuts a circle only once here. Therefore, we have got the right to say that therefore this thing is called a tangent. I hope it is clear. So, there are basically many, or rather few, corollaries and theorems which you might have to know about the tangents. And the first one we're going to look at is tangent from the same point. From the same point. So, basically what it means is that when we have got a circle and we have got two tangents coming from a similar point, point X, we've got the right to say that this tangent is equal to this tangent. So if this was A and this was B, we can say that tangent AX is equal to tangent BX. Obviously. So always you must know that you don't have to know the proof behind this, but just know that tangent AX is equal to tangent BX. Why? Only because they are tangents and they are coming from the same point, which is point X. I hope it is clear. So if it is given in a diagram in the exam or in a test, and you see two tangents coming from the same point, then you can conclude that the two tangents are equal. Meaning that if this one is 5 millimeters, we can say that even this one is 5 millimeters. I hope it's clear. So the second one we're going to look at is the tan-chord theorem. In this lesson, I'm not going to prove it, but I will prove it in the next lesson. So, we've got a circle, we've got a tangent, and we've got a chord, right? So, basically this theorem is very easy and it's so similar. It appears many times in the exam room. So make sure you know this. I'm not saying it's the only one which comes, but many of them, but this one in most cases is there. So suppose you've got A, B, C, D. We know that CD, or rather ED, is a tangent, alright? Why? Because it touches the circle at one point. They won't tell you that it's a tangent, but you must know that it's a tangent. So the tan-chord theorem says that an angle between a tangent and a chord, let me just write it. An angle between a tangent and a chord is equal to the angle in alternating segment. We use acronyms in geometry, but feel free to write these things in full. So what we mean when we say an angle between a tangent and a chord, where's our tangent? Here's our tangent, right? And where's our chord? We said a chord must touch the circumference 2 point, but not passing through the center. There is our chord BC, right? So where is the angle between the chord and the tangent? Obviously, is this angle here, right? So the angle between this chord BC and tangent ED is equal to the angle in the alternating segment. Remember, you place one hand on point B and you place one hand at point C. You move up and you move up. Where those two arrows meet, it's where the other angle is. And where they meet is where this angle here will be equal to the angle between the tangent and the chord. So if here it was angle X, for example, therefore here it will be angle X as well. Okay, so we must know that an angle between a tangent and a chord is equal to the angle in the alternating segment. Similarly, we can do it on the other side. We can say that we now take, okay, let me just clear up the colors there so that it's more visible. Okay, so now let's do from the left side. Still, this is our tangent, and we've got a chord. This is a chord here, right? So where is the angle between the tangent and the chord? Is this angle. And we want to know, suppose it's angle y, we want to know what angle again is equal to y. You place one hand at A and you place one hand at C, and you move like this and you move like this. Then where those two arrows meet, that's where the other angle is. Therefore, this means that angle y is again here. We can say that angle AC with a cap B is equal to angle B. Okay, so the notation is very important. Why are we saying ACB and putting C in the middle? Because C is the angle, it must be in the middle, and we use the cap to denote that it's an angle, right? So you must know that if we've got the tangent chord theorem, you see, it's termed the tan chord theorem because it's an angle between a tangent and a chord. Between a tangent and a chord is equal to the angle in the alternating segment, right? So whenever you've got an angle between a tangent and a chord, if here is 30 degrees, you must know that the angle in the alternating segment is also 30 degrees. And similarly, if here we've got 60, here we're going to have 60. I hope it is clear. Thank you for watching.